Today, we are going to talk about properties of vectors. What is property of vectors? Well, property of vectors, the first thing of property of vectors is that they have two-dimensional vectors which represented graphically or geometrically. And there are two definitions of characteristic that a property of a vector should have, which are the magnitude and its direction. This we can use an example like an arrow. An arrow have a head and a tail and a head, which is also called as a terminal point. The magnitude of its and an arrow also have a magnitude of its direction. Well, property of vectors, dif- even though you add them up, you will get the force and velocity. And for the commutative law, which is stated by the additional vectors, which means even though you add the vectors not differently, it doesn't matter. We'll know about this in the next few slides. Well, this is the first vectors, which is called commutative property of addition, which is a plus a equals to b plus a. This is the same because this is called a parallelogram law. Here are two sides of edges that is defined as a plus b, and there's also one defined by b plus a. But they are the same diagonal law of the parallelogram. Well, this one we can either set the example, which is 1, 2 plus 3 and 2. This is equals to 3, 2 plus 1 and 2. No matter, this is the same just because the answer you'll get is the same. Is even though you add 1, 2 with 3, 2, you'll get 4, 4. And 3, 2 with 1, 2, you'll also get the same answer, 4, 4. So this step is proven that the answer are the same no matter who goes first. So this is another law which is called associative law, property of addition, which is a plus b plus c equals to a plus b plus c. What is the difference? The difference is everyone knows we need to do the bracket first before the normal calculation. So even though you do the bracket a plus b first, or you do the bracket b plus c first, it will be the same. So the example I gave here is 1 2 plus 3 2 bracket plus 2 1, and this is equals to 2 1 2 plus bracket 3 2 and 2 1. This is proven because the answer we'll get is the same no matter which one you're going to add first. You can add AB first or BC first, no matter what, because you get the same answer. So the law is addition, identify, or inverse property. So this law, we need to add a vector with 0. If we add a vector with 0, we'll get back the vectors. Or we can add a vector plus negative vectors will equals to 0. This is the same answer. It's like you're moving you're moving the first a to in front of the equal and moving 0 behind the equal, and we'll get the same thing, which positive will become negative and a plus negative a equals to 0. So the example I gave for a plus 0 equals to a and a plus negative a equals to 0 is I gave up the vectors 1, 2 plus 0, 0. This is equals to 1, 2, or this is equal to the same vectors 1, 2. Or we can use another way, which is inverse property. We can use 1, 2 plus negative 1, 2, which is also equals to 0, because positive and negative, when they combine together, they'll be negative. So no matter which vectors go first, or where the position of the vector is, you'll get the same answer. You'll get the same vector because any number or vector plus 0 will get the same thing. And for a vector and for inverse, a vector which minus its own vector will get 0. So the fourth law, the distributive property. if you have a scalar c multiplied into a plus b, then it's the same thing as ca plus cb. In normal math, even though there is a number in front of the bracket, we need to first multiply the number into the bracket. So this is common because c multiplied by a will become ca, and plus c multiplied with b will become cb. So the example I gave here is 3, 1, 2 plus 3, 2, which equals to 3, 6 plus 6, 9. Because 3 multiplied by 1, 2 will be 3 and 6, and plus, keep the same, 3 multiplied with 3, 2 will become 6, 9 and 6. So if you multiply c into the, if you multiply any numbers, which is c into the bracket, will get the multiplication, a normal simple multiplication. So the fifth vector, the distributive property. What is distributive property? It's CD multiplied by A, which is equals to C multiplied DA. Why will this happen? Because CD multiplied by A, the three things multiplied together will become CDA. So even though we put C outside of the bracket and we put DA into the inside of the bracket, C will multiply inside. So, and if we put CD inside a bracket and put A outside of the bracket, we'll get CD multiplied with A, which will get the same answer, ACD. So what is the example I gave here? The example I gave here is 3, 2 multiplied with 1 and 2, which will equals to 3 multiplied by 2 and 1, 2. The answer will be the same because like what there is in the picture, we'll see 2 plus 7 plus 5 equals to 2 plus 7 plus 5. This is the same. The difference is you put the bracket differently. 2 plus 7 will equals to 9 plus 5 will get 14, and 2 plus 12 will get also 14. So the sixth vector, multiply multiplicative identity property, which is 1a, 1 multiplied by a will equals to a. So a number 1 multiplied with another number will equals to the same number. No matter what number multiplied with 1 will be the same number, or even vectors. So the example that I gave for this one is 1 multiplied by 1, 2 equals to 1, 2, because everyone knows basic multiplication. So in basic multiplication, everything multiplied by 1 will equals to its origin number. So this is the proof that the answer we got is the same, because 1 multiplied by any number or any vector will be the same vector or number. And that's it. We are done for our property section.